Hi everyone, we're going to be doing trigonometry today. We're going to be using our SOHCAHTOA. You guys have probably heard that before. So remember just to reference our sine of b. So our b value here, the angle it's always talking about is actually b. So that's what that little symbol right here, it tells us what angle we are talking about. So if we're using the sine, we have to use the opposite over our hypotenuse. So opposite over hypotenuse, that's what we will be dividing by. Then we have our cosine of b. Now our cosine of b is actually the adjacent over the hypotenuse, so you guys can see where these sides are actually labeled. The adjacent is the one helping make up that angle. Opposite is the side completely not touching that angle. Hypotenuse is always directly across from that 90-degree angle. So again, we don't have a hypotenuse here for our tangent, but we do have to use the opposite over adjacent for our tangent. And that's where that acronym came up with. So that is our SOHCAHTOA. You can also see it here. So we're going to label the sides of the triangles below with an O for opposite, A for adjacent, H for hypotenuse. So the angle it's actually talking about is right here, the one that we have the angle mark shown. So according from this angle, what side is the opposite side of that angle? So if I go directly opposite, that's that side. This angle that is adjacent, that's actually making up that angle, is here. And then the angle, or the side that's always opposite the right angle is your hypotenuse. So again, we have our hypotenuse directly across from our 90-degree angle. That will never change. And now my angle is over here. So now I have my angle there. So now what side is opposite? We see that all of a sudden this side's actually opposite when it was adjacent here, because we are talking about two different reference angles, this one here and that one there. So which means that this is my adjacent side, because that is the actual angle, that is the side that's making up that angle. So I'm going to have you guys go ahead and do the other two on your own, and I will go over those in class with you just to make sure that you guys actually labeled those other two triangles correctly. Then we're going to express sine A and cosine A tangent A, sine B, cosine B, and tangent B. So we're going to go ahead and show you how to do a couple of these first. So sine A means I'm referencing this angle first. And remember, I'm going to go ahead and write SOHCAHTOA just so I remember my different ratios that I need to actually divide by. So if I have I have to use sine of A, this equals, I have to use opposite over hypotenuse, which means that I have my opposite side, which is 3, over the hypotenuse, which is directly across from that right angle. However, I have an irrational number in my denominator, so now I have to rationalize my denominator by multiplying by that square root of 13. So now I have 3 square root of 13 divided by 13. I cannot simplify that, so this is my sine of A. Now I'm going to go ahead and go on to my cosine of A. I'm still going to be using this angle. However, I am going to have to use my adjacent over my hypotenuse. So if I have adjacent this time, this is the side making up that angle A. So I have my adjacent, my hypotenuse is still the same of that square root 13. Have to rationalize it again because it's an irrational number in that denominator, which means I get 2 root 13 divided by 13. And my last one that I have for tangent, so if I have tangent of A, we're going to go again from that same angle, and now I have to use my opposite over adjacent. Now from this angle, that opposite side was that 3, so I have 3 over, and then my adjacent was the 2. So I have 3 over 2, and that's actually my final answer. I can't simplify my fraction, and I don't have anything to rationalize. So go ahead and do your sine B, cosine B, and tangent B. We will try them, and I'll check for them in class as well. You're going to identify the following trig values, leave as a simplified fraction and in simplest radical form. So here we're just identifying the sides. So again, keep writing SOHCAHTOA over and over and over again so that we know what our actual ratios are. So if we have sine L, we're going to be going from this angle there. We have to use our opposite, which is 6, over our hypotenuse, which is always going to be directly across from the right angle, which is 10, I know that 2 goes into both of those, so this fraction simplifies to 3/5. Okay, now I'm just going to go on to B, so cosine of L now. So now I have my cosine, which means I have my adjacent over my hypotenuse. Again, your hypotenuse will never change, and that means I have 2 going into both of these again, so I have 4/5. Now I'm going to have my tangent of L, which means I have opposite over adjacent, opposite of that angle still, over my adjacent, so I have 6/8 now, and I know that 2 goes into those as well, so I have 3/4. Now, if I do my sine L, we're actually going to be changing the angle that we are talking about. So if I change that angle, I am now going to see that I am at angle N here, and now I have my opposite for sine over my hypotenuse, which is still 10. Doesn't matter where that angle is, it's always across from that 90-degree angle. I know that 2 goes into both of those, and I get 4/5. Now I have my cosine of N, which is now my adjacent. This is now my adjacent side, which is 6/10. See how the adjacent and hypotenuse actually switch over, so be careful on those. The adjacent and opposite switch. So you can see here, they switch over. Those are the same, but they switch when you're talking about different angles. And then we have our tangent, which is still the opposite over the adjacent from this angle N, so we have 8/6, which then gets us 4/3. You can see that that just rotated like this. So that's how you have to make sure that they are actually you're referencing the correct angle and using our trig ratios here in order to do those. So go ahead and do the other 3 on your own, and we'll go over those in class as well. Just kidding. You have to do the last these 3 on your own. I actually did all those for you. So we are now going to identify the sine and cosine of the tangent B. So for here, this would be very easy so we're talking about our sine B right here, we're talking about this angle. However, I'm missing a side, so what would I do in order to figure out that side? I can't just put x there, I want an actual value, I need to simplify my fractions. So what I'm going to use is the Pythagorean theorem in order to figure out that second side. So when I go ahead and do x squared, 7 squared is 49, 10 squared is 100. We're going to subtract 49 from both sides, and we end up getting 51. So we take the square root of that. A lot of you guys are forgetting to do that at the last second there. And I believe 51 is prime, so it's just going to leave as square root of 51. So that's what this value is going to represent. So we want to include that when we're discussing our trig functions. So if we have sine B, we are now at this angle. We have to use the opposite over our hypotenuse. So we have a square root of 51 divided by 10. I cannot simplify anything here, so that's my final answer. Now we need to reference, it's still going to be our angle B, but it's going to be cosine this time. And when we get cosine of B, we have our adjacent to that angle, so 7 over our hypotenuse, which is 10. Cannot simplify 7/10, so we stay as 7/10. Then we have our tangent, and again that angle, we have our opposite over our adjacent. So if our tangent, we're going from angle B, we have opposite, square root of 51, over our adjacent. And that is our final answer again. We cannot simplify that. So the difference here, we're missing a side, use Pythagorean theorem. Okay, so now we're going to be talking about missing angles and sides. This is when we're going to be using our trig ratios here. So if we are missing our side, first of all, we need to figure out what sides we actually have given to us. So we do have an angle here. Our x is on the outside, it's representing a side. So according from the angle I actually give you, what are the x and the y according to this angle? So right here, I have an opposite, so I'm actually going to label this O, and I have an adjacent. So which letter out of SOHCAHTOA has an O and an A in it? We see that we're going to be using tangent. So if I have tangent, and then instead of actually using the letter, we actually have a degree measure there of 55. equals our O over our A, so x over 8. Now we need to actually get x by itself. We're going to multiply both sides by 8, and this is what we actually put in our calculators. So we will be using calculators. 8 tan 55 equals x. So when we actually put that in our calculator, 8 tan 55, we end up getting 11, and we're running to the nearest tenth, 11.4. So that is actually our side length of our opposite side from that angle. Now I see that I have an angle here, however it's an x. That's okay. I'm going to still reference it. We just are going to have to use our inverse of our trig functions. So this is where we have like the sine to the -1, cosine to the -1, tangent to the -1. So either way, I'm going to go from this angle and I'm going to determine what those sides are according to those values. So this is my opposite. This is the hypotenuse because it's directly across from that 90-degree angle. So what two letters out of SOHCAHTOA, or what letters out of SOHCAHTOA has an O and an H? We said that it's going to be sine. So I'm going to set up sine x. We don't know our angle. We have our opposite over our hypotenuse. So in order to get rid of x here, we don't just divide by sine, you actually have to use the inverse. So I would now say x equals, and now I bring over that sign over here, but it has to be that inverse to the -1, and I put in my calculator divided by 1520 divided by 23. So in your calculator, you have to do the sine inverse button. I will show you guys this in class, but please just write this down for now. And we will do 15 divided by 23. Again, we're rounding to the nearest hundredth, so we have 40.7. And be careful because we just figured out an angle, a degree measure, so this is a degree. So anytime the x is inside the radical, we're using inverses. Anytime the x is on this side, we don't have to use inverses, we just use our trig functions. Thank you guys. I will see you in class.